Welcome to the DIY Honda Garage channel. The DTC P0980 indicates an open condition in the shift solenoid valve C circuit of the Honda Odyssey model years 2011 to 2017. This solenoid is crucial for the proper operation of the vehicle's transmission, particularly in ensuring that the transmission shifts smoothly between gears. The purpose of the shift solenoid is to control the flow of transmission fluid, which in turn facilitates engaging and disengaging gears to optimize performance. The location of the shift solenoid valve C is within the transmission and is connected to the powertrain control module PCM via an electrical harness. A failure in the electrical circuit associated with this solenoid, rather than a mechanical issue, triggers this fault code. As a result, the vehicle will not shift into second or fifth gear due to a fail-safe function to protect the transmission from further damage. Accurate diagnosis and repair are essential for restoring proper shift function in the vehicle. The DTC P0980 signifies an open circuit condition within the shift solenoid valve C, which is integral to the transmission system's functionality. The shift solenoid is a critical component that regulates hydraulic pressure to shift gears effectively. Situated within the transmission assembly, it operates under the direction of the powertrain control module, PCM, which controls its activation based on various inputs. When an open circuit occurs, the PCM receives no signal from the shift solenoid C, which directly affects the transmission's ability to shift into second or fifth gear. This design is intentional, as it creates a fail-safe condition to prevent potential damage to the transmission. Identifying and rectifying this open circuit is crucial for restoring shifting capability and ensuring appropriate vehicle performance. The DTC P0980 can stem from several possible causes, mainly centered around electrical issues. Firstly, an open circuit in the electrical wiring connected to the shift solenoid valve C can lead to this error code. Unlike some other transmission-related problems, this specific DTC does not suggest any mechanical failures within the transmission itself, which is critical for technicians to understand during diagnosis. Another potential cause includes poor electrical connections or loose terminals found between the shift solenoid valve C and the PCM, which could disrupt the signal transmission. Additionally, a blown number B5 fuse located in the underhood fuse/relay box can further prevent the solenoid from operating. Correctly identifying these causes will facilitate an efficient and effective troubleshooting process. Symptoms associated with the DTC P0980 primarily involve the transmission's inability to shift properly. The most noticeable symptom is that the vehicle fails to shift into both second and fifth gears, which is indicative of a malfunction in the electrical circuit. Drivers may experience the sensation of the vehicle being stuck in lower gears, which can lead to reduced acceleration and overall poor performance. Additionally, it is common for warning lights on the dashboard, such as the check engine light, to illuminate as a testament to the transmission's failure to operate normally. These symptoms not only affect drivability, but can also lead to increased wear and tear on the engine, if not promptly addressed. In troubleshooting DTC P0980, the initial step involves turning the ignition switch to the on position, which energizes the vehicle's electrical circuits. Following this, the diagnostic tool known as the Honda Diagnostic System, HDS, will be employed to clear the DTC currently stored in the powertrain control module, PCM. Clearing the DTC allows for a fresh assessment of the system's condition. After clearing, it's essential to start the engine while ensuring that the brake pedal is pressed. This prepares the vehicle for a test that evaluates its transmission responsiveness. The operator should then let the vehicle idle for a moment to permit the system to reset. allowing for further diagnostic checks. The second troubleshooting step involves using the Honda Diagnostic System, HDS, to check for any pending or confirmed DTCs once the engine is running. This diagnostic review will reveal if DTC P0980 is still present in the system. The presence of this code after previous clearing may indicate a persistent issue that requires further investigation. Technicians utilize the HDS to probe deeper into the system's electronics and gather real-time data indicative of the transmission's performance. If DTC P0980 is present, it confirms an ongoing problem with the shift solenoid circuit. Conversely, if no code exists, this may suggest an intermittent issue, potentially caused by a poor electrical connection or temporarily resolved failure. In the third step of troubleshooting, the ignition switch must be turned to the lock position to ensure safety while inspecting electrical components. The next critical task is to check fuse number B5, which is a 7.5 amp fuse located within the underhood fuse relay box. This fuse plays a pivotal role in supplying power to the shift solenoid valve circuit, and if blown, it will directly affect the functionality of the valve. Replacing a blown fuse without addressing the underlying issue won't resolve the ongoing DTC P0980. Thus, it is essential to confirm whether the fuse is intact. If the fuse is operational, the technician will continue to the next troubleshooting step. If not, an examination for a short circuit to body ground in the associated wiring will be required. The fourth troubleshooting step requires jumping the short circuit detection (SCS) line using the HDS, which allows the diagnostic tool to bypass certain safety checks temporarily. Following this step, it is necessary to disconnect PCM connectors A, specifically the connector labeled as A49P, to access the wiring directly involved with the shift solenoid circuit. Once the connector is detached, the ignition switch should be turned back to the on position. 2. This allows for ongoing diagnostics and voltage measurements. This disconnection is critical as it helps to isolate components and check for wiring issues or internal failures within the PCM or the solenoid circuit without interference. Step 5 focuses on measuring the voltage at the PCM connector, particularly between terminal A1 and body ground. This test is essential for determining whether battery voltage is present at the connector, which signifies that power is reaching the PCM from the fuse box. Using a reliable multimeter, a technician will evaluate this specific voltage reading. If battery voltage is present, it confirms that the circuit is complete up to this point, and the issue likely lies beyond the PCM. Conversely, if no battery voltage is present, this indicates an open circuit, necessitating repairs to the wiring between the PCM connector terminal A1 and the underhood fuse relay box. This step is crucial for pinpointing where the electrical failure is occurring in the circuit, and it directly influences the next diagnostic actions. Upon completing all repair actions associated with DTC P0980, final verification is crucial to confirm that the issues have been resolved. The first step in this verification is to properly reconnect the PCM connectors that were previously disconnected. Following the reconnection, the technician will start the vehicle and allow it to run for a few moments. This process will help the system reset, allowing for accurate evaluation of the functionality of the transmission once more. After running the engine, it's necessary to check the HDS for any remaining DTCs. If DTC P0980 reappears, additional investigation is warranted, which may involve revisiting previous steps and double-checking connections and circuit integrity. Preventive maintenance plays a vital role in avoiding future occurrences of DTC P0980. Regular inspections of the wiring harness associated with the shift solenoid and PCM are crucial, as visible damage or wear can lead to intermittent or complete failures. It's equally essential to check electrical connections regularly to ensure they are tight and free from corrosion. Loose or corroded connections can often create a pathway for faults that result in DTCs. Another preventive step is to replace blown fuses immediately instead of delaying. This not only ensures that the electrical system operates correctly, but also prevents any further potential damage that may arise from unresolved electrical issues. Implementing these maintenance measures can contribute greatly to the trouble-free operation of the Honda Odyssey transmission system. Corrective actions alongside thorough testing help in ensuring that the vehicle operates within normal parameters again. Moreover, adopting preventive maintenance practices enhances the longevity and reliability of the Honda Odyssey's transmission system, ultimately improving the driving experience and minimizing future repair costs. Please like and subscribe to the channel. See you next time.